Pál Turán was a Hungarian mathematician who worked primarily in number theory. He had a long collaboration with fellow Hungarian mathematician Paul Erdős, lasting 46 years and resulting in 28 joint papers. Life and education. Turán was born into a Jewish family in Budapest on 18 August 1910. He received a teaching degree at the University of Budapest in 1933 and the Ph.D. degree under ʻpaː in 1935 at EOTVO's Lorand University. As a Jew, he fell victim to numerous clauses, and could not get a university job for several years. He was sent to labor service at various times from 1940 to 1944. He is said to have been recognized and perhaps protected by a fascist guard, who, as a mathematics student, had admired Turán's work. He became associate professor at the University of Budapest in 1945 and full professor in 1949. First he married Edda Kóbor in 1939 and had a son Robert. Then he married mathematician Vera Szós in 1952 and they had two children, György and Tamás. He died in Budapest on 26 September 1976 of leukemia. Work. Turán worked primarily in number theory, but also did much work in analysis and graph theory. Number theory. In 1934 Turán used the Turán sieve to give a new and very simple proof of a 1917 result of G, H, Hardy and Ramanujan on the normal order of the number of distinct prime divisors of a number n, namely that it is very close to lane n. In probabilistic terms he estimated the variance from lane n. Halas says, its true significance lies in the fact that it was the starting point of probabilistic number theory. The Turán-Cubilius inequality is a generalization of this work. Turán was very interested in the distribution of primes in arithmetic progressions, and he coined the term prime number race for irregularities in the distribution of prime numbers among residue classes. With his co-author Napovsky he proved results concerning Chebyshev's bias. The Erdős-Turán conjecture makes a statement about primes in arithmetic progression. Much of Turán's number theory work dealt with the Riemann hypothesis and he developed the power sum method to help with this. Erdős said Turán was an unbeliever, in fact, a pagan. He did not believe in the truth of Riemann's hypothesis. Analysis. Much of Turán's work in analysis was tied to his number theory work. Outside of this he proved Turán's inequalities relating the values of the legendary polynomials for different indices, and, together with Paul Erdős, the Erdős-Turán equidistribution inequality. Graph theory. Erdős wrote of Turán. In 1941 he created the area of extremal problems in graph theory, which is now one of the fastest growing subjects in combinatorics. Peter Frankl said about Turán, he fell victim to numerous clauses. Mathematicians have only paper and pen. He doesn't have anything in camp, so he created combinatorics, which is not needed both thing. The field is known more briefly today as extremal graph theory. Turán's best known result in this area is Turán's graph theorem. That gives an upper bound on the number of edges in a graph that does not contain a complete graph Kr as a subgraph. He invented the Turán graph, a generalization of the complete bipartite graph, to prove his theorem. He is also known for the Covariesso's-Turán theorem bounding the number of edges that can exist in a bipartite graph with certain forbidden subgraphs, and for raising Turán's brick factory problem, namely of determining the crossing number of a complete bipartite graph. Power sum method. Turán developed the power sum method to work on the Riemann hypothesis. The method deals with inequalities giving lower bounds for sums of the form, hence the name power sum. Besides its applications in analytic number theory, it has been used in complex analysis, numerical analysis, differential equations, transcendental number theory, and estimating the number of zeros of a function in a disk. Publications. Ed. by P. Turán. Number Theory. Amsterdam. North Holland Pub. Co. ISBN 978-0-7204-2037-1. Pál Turán. On a New Method of Analysis and Its Applications. New York. Wiley Interscience. ISBN 978-0-471-89255-7. Deals with the power sum method. Edited by Paul Erdős. Collected Papers of Pál Turán. Budapest. Akadémia Kiadó. ISBN 978-963-05-4298-2. Honours. Hungarian Academy of Sciences, elected corresponding member in 1948 and ordinary member in 1953. Kossuth Prize in 1948 and 1952. T. Basile Prize of János Bollier Mathematical Society 1975.